Used to work at Tinker and ran a lot of Arduino training courses. And we were looking at doing robotic stuff with the students. I don't have a glossy presentation, I tend not to do glossy presentations. And there is a live demo of sorts, but I found out the one thing that I didn't test was plugging in a MacBook running Ubuntu to a Thunderbolt VGA adapter, and that doesn't work. So I can either boot into Ubuntu and control the robot, but you can't see anything on the screen there, or I can show you stuff but not control the robot. So we'll look at some stuff, we'll talk about ROS, and then I'll fiddle about with the robot a bit, and we'll play around with that a bit. So at Middlesex we were looking for a robotic platform to do stuff with students, and a classic issue with a lot of robot stuff is that you get to control the motors that drive around. The robot that we're going to play with there, classics are a circular robotic base that will drive around. And you work out how to drive the motors, you work out how to turn them on and off, you work out how to steer them, you can do a bit of driving about, and you can do the kind of stuff that they were doing with Logo years ago. And then it gets really, really, really complicated. Really, really hard. And a lot of robotics research projects end up spending all the time that they're supposed to be developing stuff actually rewriting loads of code to do all the things like planning the path that they're going to take through things, detecting stuff and working out what it is, because there was no kind of agreed standard about how you would do that. So code people had used on one project, you couldn't necessarily use on another, because there wasn't even agreement about when you're talking about X, Y, Z, do you talk about it being that, or do you talk about it being that? And if all your code is written using that, and someone else used this, then you're getting a lot of complication getting it to work. But when you're talking about rotation, are you talking about that, or are you talking about that? So there was a lot of incompatible stuff out there, a lot of stuff that people wanted to use. And then there's a company called Willow Garage. They're American, so you say garage and garage. And they make robots, and they're the maintainers of OpenCV. Have people heard of OpenCV? So OpenCV are very well respected open source computer vision libraries. So if you're going to do computer vision and you don't write it from scratch, you use OpenCV. So Willow Garage have been maintaining that for quite a few years because they make robots. And so having a really good vision platform for robots is clearly quite important. And they feel that maintaining OpenCV and sharing it with the community and having other people using it means that they end up with a more powerful product. Because what they do is they sell robots, they don't sell software. So OpenCV is available. So guess how much one of these costs?
Approximately 40, 50,000.
Okay, the big clue is that as you go down here, before you get obtain quote, you get ways to search for funding. That's always a bad sign, and then it says obtain quote. So if we go to obtain quote, so obtain quote, $280,000 with the 30% open source discount, but not including taxes and shipping. So it's going to be a bit more. So charging for the software is kind of neither here nor there. PR2 is a very, very serious research robot, but they actually got involved in donating loads of them to people who wanted to use them. So they sold a load for $10,000 as long as people contributed source code to the community so that other people could use it. And what Willow Garage started to work on was a thing called Robot Operating System. So Robot Operating System, which we would have a link to on their main page here, Robot Operating System is middleware. It runs on a computer that's already running an operating system, and it handles a lot of the specific things that robots need to do. And a lot of the slides that have been coming up today, I mean, ROS is a classic example of a domain-specific implementation of things like nodes and communication protocols. So the specific domain is about robots and getting them to move around. For a few years they've been maintaining it, but they've just floated it out, and there's an open source robotics foundation, which is now the home to ROS. They've been releasing very aggressively. They've been mirroring the Ubuntu releases, so about every 6 months there's been a major point release. It's been going about 5 years. It's being used very heavily in universities, so almost every university that has any kind of significant robotics action, they're using ROS. So a huge amount of contributed code. And it's fairly simple, really, he says. And then he will totally fail to get it to work in any way, shape or form. Let me just check my notes and see if I've said all the things I thought I would say at this point. This is the closest I get to a PowerPoint presentation. So the key thing that they wanted to do was use stuff that's available rather than reinvent stuff. So it's about plumbing things together rather than writing new code. It's about taking things that exist and plumbing them in. If something starts to get big, then spin it out and make it a separate thing rather than keep it as part of ROS. So they're very keen to use other stuff and get other people maintaining their things individually. At its core, it's about plumbing. It's about message passing. It's about talking to the base and telling the base to move somewhere, the base giving you information back about where it is, talking to something like a Connect and getting messages from that, and joining them together. So what you need to know is what's the difference between where the wheels are and where the camera is that's recording stuff. Or if you've got a multi-joint arm, when this is here, what do I need to do to control this point? And what do I need to control this point? So you end up doing lots of things called transforms, where you're calculating what's the orientation of this, how is it related to that, how is it related to that, and you have something that's defined as the base. So they've developed a thing called a unified robot description format, which is an XML format for representing a robot model. So you build a UDRF model of your robot, and that's kind of things like how far apart are the wheels, how high up is the Connect. If it's an arm that moves around like this, how long is that bit? How long is that bit? What kind of movement have you got there? How many fingers has it got? And once you've got that URDF model, you can then interface it to pretty much all the stuff that ROS does. So your really fiddly bit is getting your URDF model done. We cheated and bought one of their cheaper robots, so you get your URDF model already. But because it's all open source, there's lots of them out there. And the documentation about how to do it is out there. It's currently implemented for Ubuntu, hence my issues with getting it to work on my laptop. They're not against implementing it on other platforms, they just haven't got the resources to do that. And most of the build process is very strongly aligned with the way that Unix works. And so implementing it for Windows at the moment is quite a difficult process. But they're aware of that, and it's still very, very young. It's only 5 years old, hasn't been going that long, so they're looking very actively about how they could implement it for other things. It's been implemented for Raspberry Pi, you can get it for Beaverbone Black, you can get it for all kinds of other things in varying states of experimental release. It's mainly available for Ubuntu and on 12.04 because that's the long-term stable release. And basically a ROS application is a group of processes running and communicating with each other. So you have a process called ROS core, and you launch that, and that's a server. And anything else that gets launched is called a node. And basically they're all separate programs, usually in C++ or Python, but you could write it in anything you want as long as it sends the messages in the right format. But all the code that they produce and show is C++ and Python. And nodes can publish or subscribe to topics. That's how you can pass messages backwards and forwards. Or they can provide services, which is basically that you can ask for something and it will send you something back. So topics are about broadcasting and receiving, services are asking and getting something back. And then there's a thing called a parameter server that basically holds global variables. So you can ask it, what's the current value for this? What's the current value for that? And the nodes can be launched independently and taken down so you can build stuff up slowly. So there would be nodes, for example, that would know how to talk to a Connect. So for this robot, you would launch those nodes. If you had another robot that had a Connect, you would use those nodes with it without having to rewrite them. And the URDF would take care of all the transformations that needed to happen because the connector was sitting in a different place on a different robot and was physically configured differently. It's network based, so once you've got a ROS core running, on that network, any computer that can see ROS core can run nodes. So you can develop stuff on one computer, and if it starts to get too difficult, you can float stuff off to other computers very easily, because a lot of the path planning stuff is hugely computer intensive. So you don't want that running on the robot, because your batteries will die very, very quickly. You want to be sending information back, calculating a path, sending the path back to the robot, so the robot then goes round it. So you can be developing stuff on one computer, you just need to move the nodes onto another computer and launch them on there, and they'll find the core and hook up and take care of everything else themselves. So the nodes form a graph, and they can arrive and leave at any time. And a complex robot soon becomes a huge myriad of processes running, and it's quite difficult to manage. But it does loads of really, really good stuff. So some of the really difficult things to solve for a robot are... Can I get this to go full screen? A thing called reverse kinematics. Have people heard of reverse kinematics?
Inverse kinematics.
Shows you how much I know about it. I don't even know the proper name. So for an arm that moves around like this, what you're interested in is where the hand's going to go. So you want to specify where the hand is, and then you need to work out how all those joints need to move to get the hand to that position. And there may be multiple combinations of positions that would work to make that happen. So starting from those coordinates, going back, working that out is quite complicated. So they have, you can get visualizers. So once you've got the URDF, you can play around with something in a visualizer, and it can calculate the paths that it will take, and it will do collision avoidance on all the joints. So you can put in a visualization of the space that it's going to work in and say that you mustn't hit these bits, and then as you drag it around, it will calculate those paths.
As environments for the robot to operate in. MoveIt can also integrate directly with the 3D sensors on your robot to build an environment representation. The kinematics and motion planning components in MoveIt use the environment representation for collision avoidance, generating collision-free paths for the robot to follow. Fast dynamic updates allow MoveIt to react quickly to changes in the environment. In this example,
$280,000 you expect.
different waypoints while sharing a workspace with a person. The robot can stop.
This is where someone comes in and obstructs it, so it works out another route to get to where it needs to go without hitting the person. And that's happening in real time. So it's detecting that the person's there and in the way, and working out a different route to take to get to where it needs to go.
Between the robot and the person. MoveIt can deal with high degree of freedom robots, allowing you to motion plan for complex tasks. For example,
And you don't have to implement the algorithms to do that. You just have to give it the parameters and tell it how close to the path you want it to stay, how you want it to vary.
Evaluating Cartesian and effector trajectories. This allows a robot designer to quickly determine how well the robot will do in different tasks before building expensive hardware. MoveIt will soon include integrated components for advanced manipulation tasks like generalized pick and place in unknown environments by integrating with object recognition and grasping. Such high-level capabilities will provide users powerful tools to build advanced applications, integrating perception, navigation, manipulation, and control. To download and start using MoveIt, visit moveit.ros.
And it's very actively maintained, very, very vibrant community. So I'll do a little bit. That's the password for that one. So this is running in VMware on the Mac at the moment, but I can't hook that up to the network to talk to the robot. It's worked in the past, but of course it didn't work today. Nothing ever works when you want it to. Okay, so if I want you've installed ROS on this machine and you launch stuff from the command line. So if we want ROS running, we get ROS core running. So we've now got the ROS server running. So I'll open a new terminal window and ask it to tell me what topics exist. So the server's running. There are only two things running at the moment. Nothing much is going on. Basic server. Here I have some things that I prepared earlier, so I don't have to forget what I'm going to type in. So I'm going to run a quick simulation. Okay, so I haven't got a robot at the moment, but I can play around with a visualization of one. And now I want a way to control it. So I'm going to start a separate node. So each of these terminal windows is starting a new node. And now I can use, if I can find the window, there you go, I can now use the arrow keys to drive the turtle about. So we're now into the 1970s single pattern territory. And our settings, it gets very confusing very quickly, so there are ways to visualise what's going on. So I can ask it to draw a graph of what's currently running. I get loads of errors, but it still works. So at the moment, there's a turtle sim thing running, there's a teleop turtle running, which is, I can use the keys to control it, and there's a topic that's going between them. Turtle 1 command velocity. Teleop turtle sends it, turtle sim listens to it. I could stop teleop, I could start another process that was talking to it as well. And for a robot with lots of controls going on, this would be just a huge mesh of stuff. And there's loads of really great debug tools like this. There's a really nice visualizer, all kinds of stuff.